Low Voltage Breaker Section 4. MCB Trip Curves, B, C, and D. Matching breaker to load, B, C, D. Welcome to Section 4. We know the MCB is the standard defender, but even the standard model isn't one size fits all. Different types of equipment create different electrical demands, especially during startup. The concept of inrush current. When you switch on a motor, a transformer, or even some lamps, they often draw a huge spike of current for a fraction of a second. This is called inrush current or starting current. The nuisance tripping problem. If a normal MCB instantly tripped every time it saw this momentary spike, it would be useless. This is called nuisance tripping. To solve this, manufacturers tuned the magnetic trip sensitivity using trip curves. What the curve represents. The trip curve defines the current level at which the magnetic unit is guaranteed to trip, expressed as a multiple of the breaker's rated current, $I_N$. We focus on the three primary types, B, C, and D. Type B curve, highly sensitive. The type B curve is the most sensitive. It is designed to trip magnetically when the current reaches 3 to 5 times its rated value. Type B application, resistive loads. Type B breakers are ideal for purely resistive loads found in residential settings, like electric heaters, ovens, or simple lighting circuits where there's little to no inrush current. They offer the fastest protection for these applications. Type C curve, general purpose. The Type C curve is the most common and versatile. It is designed to tolerate a medium surge, tripping when the current hits 5 to 10 times its rated value. Type C application, motors and fluorescents. If you are using general power sockets, small motors, fluorescent lights, or other common commercial appliances, you are almost certainly using a Type C breaker. It strikes the best balance between protection and avoiding nuisance trips. Type D curve, heavy-duty loads. The Type D curve is the least sensitive, built to handle massive, but short-lived, current spikes. It trips only when the current reaches 10 to 20 times its rated value. Type D application, high inductance. This curve is reserved for highly inductive loads with very large inrush currents, such as large industrial motors, welding equipment, or high-power transformers. Using a Type C here would cause constant tripping. Thermal trip remains constant. It's important to remember that the thermal trip setting, the protection against sustained overloads, remains virtually the same across all B, C, and D curves. Only the fast-acting magnetic trip point changes. Up next, MCCB power. Understanding these curves ensures the right breaker is protecting the right circuit. Now that we have mastered the MCB, it's time to move to the bigger leagues, the powerful, customizable MCCB, or mold case circuit breaker.